Welcome back to the channel, everyone, and today we'll be looking at the inverse of a matrix. So this is a popular type of question on your exam, and it's important that you know the exact procedure to follow. So let's get right into it. So when you're asked to find the inverse of a matrix, it means that you were given an original. So let's say our original was matrix A, and we have the elements A, B, C, D. So remember, the order is 2, so that's 2 rows by 2 columns. So you can write the order anywhere. So this is your order, a 2 by 2 matrix. Now when you're asked to find the inverse of this matrix, you need something called the determinant. So that's like a special code you use to really have some information on the original matrix there. So we represent the determinant as this. So we need the determinant. That's the first thing. So this is the key thing, one of the key things we need. So the determinant, and its formula is, so you need the original matrix here, and you represent the determinant by this. Alright, so how you find that now? It's just the product of your leading diagonal, so that's AD. So that's A multiplied by D. So let me do it step by step. And you need to subtract the product of your second diagonal. All right, so that's BC. So overall, the determinant of your matrix is AD minus BC. So remember, these are just variables I'm using to represent what we really need. So we'll ultimately do an example involving real values. Okay, but this is the determinant, and then you need a next thing called the adjoint. So this is another little special thing that we use to find the inverse. All right, so with the adjoint, all you have to do really is switch your leading diagonals. So A would now be in D position and D is in A position. So switch them. So this is now D, this is now A. And then with your second diagonal now, you just change the signs. So if this was a positive C, it will now become negative C. And if this was a positive B, it will now become negative B. So we are now one step closer. So this is what we call our adjoint of a matrix. So we're really just, rearranging or changing some things from our original in order to find out what is this new thing. All right, so we need these two in order to find it. So when we're asked to represent the inverse of a matrix, your formula is, so whatever your original matrix is, you have to have the name of that one, and you represent the inverse by attaching a -1 as its power. So that's the regular representation of inverse. All right, and with that, you need your determinant, so we're going to use this symbol. So it's the inverse, or 1 over what your determinant is, multiplied by your adjoint. So as I said, we're going to use both of them, and we're going to try an example. All right, and this is what you do to get your inverse. So that is the basic idea behind it. So let's get into an example. Okay, so this is our question. So it says find the inverse of the matrix P when matrix P is equal to 2, 1, 4, and 3. So remember, this is also a 2 by 2 matrix, so these still apply. So in order for us to find the inverse, there's a special representation. So it's our original raised to the power of -1 So we need our original raised to -1 is equal to whatever the determinant is. So remember the specifics. Alright, so whatever the determinant is multiplied by your adjoint. So at this stage, you can simply insert your adjoint based on the original rule. So it says you switch the leading diagonal. So here, this is our leading diagonal. So 2 is in the first place and this one is in the fourth place. So we switch them. So 3 would go up here, 2 down here, and now we have 4 here and 1 up here. So remember, these stay in the same position, but it's just the sign that changes. So the 4 stays. It was originally positive, it's now negative. The 1 was originally positive, it is now negative. So we're one step closer. So we have the adjoint. We don't know what the determinant is as yet, and we have our little symbol here. So the inverse of P is equal to 1 over, and our rule states that the determinant is AD, so our leading diagonal, the product of the leading diagonal, minus our product of the second diagonal. So AD, the 2, 3, 2 multiplied by 3 minus your second diagonal. So that's 4 by 1. Multiplied by your adjoint, just the same. So each and every step, just bring back, just to remind yourself that you're finding the inverse of P. Okay, so you put back your 1 here, and it is standard to have the 1 right here. Okay, that's why it's there. So inverse, we have to have 1 over something. That's usually the inverse of something else, or the reciprocal of something else. So the determinants are 2, 3, 6 minus 4. Bring back your adjoint again. Okay, this can be simplified a little bit. So the inverse of P is equal to 1 over 2. So our determinant is 2 when we simplify, and you multiply it by whatever your adjoint is. So in the end, given that we are now at this step, inverse of P is equal to, so this, your determinant is multiplied by everything inside this little cell right here. So first number is 3. It's divided by 2. So it's 3 over 2. The next one is -4. So -4 over 2. The next one is -1 over 2. And the other one is 2 over 2. Once you get to this stage, all you have to do is look to see if there is any that can be reduced in any way. So the 3 over 2, you can leave that as is. -2 over 2, these can be simplified. So you're left with -2. Because a negative divided by a positive is still a negative answer. This is -1 divided by 2. This can remain the same, and 2 divided by 2, that is 1. And this would be our inverse for our, original P that we were given right here. So all you have to do is just remember the main steps. So when you're asked to find the inverse, you need both the determinant and the adjoint. All right, they are linked together to form a unique matrix that is completely opposite to your original, so that whenever you multiply them together, you can get the identity matrix of 1, 0, 0, 1. So let me know if this video assisted any at all. Let me know if there's something else you would like to see, and I will try my best to upload. Thank you for making it Mathsis4U.